So this is 4.4 part 2, right? And in part 1, we talked about finding the values of any trig functions, right? Because before we learned right angle trig functions, and then in this last bit that we did, we were talking about the finding the value of a trig function no matter what the angle was. And today we're going to talk a little bit about the trig functions at the trig functions at quadrantal angles, which I will explain what a quadrantal angle is. And then we'll get to the reference angles. So if we have a graph, right? And we have on that graph our points, right? Here we'd have our point at, let's say these are all 1 unit. And here we have 0, right? We've got 0. Here we have pi over 2. Here we have pi. And here we have 3 pi over 2. But we also have points at these, right? We would have x equals 1, y equals 0 here. And we'd have x equals 0, y equals 1 here. And here we would have x equals -1, y equals 0. And here we would have x equals 0, y equals -1. And so we have these points, and what we consider each of these points to be, this pi over 2 angle or 90-degree angle, that is one of our quadrantal angles. This line right here is another, that 180-degree angle is a quadrantal angle, right? 3 pi over 2 is a quadrantal angle. So we're talking about the angles that are sitting right on the axes. That's all it means. That's all quadrantal angles are. And so what we're going to do is we are going to evaluate cosine and tangent. We could do any trig functions, right? But we're going to evaluate cosine and tangent at the quadrantal angles, which are 0, pi over 2, pi, and 3 pi over 2. So we are only doing cosine and tangent. So let's look at 0 first. If I look at the cosine of 0, based on what we did last time, if you look at your chart from last time, we know that that is just x over the radius. Now, here's the cool thing is with all the stuff we had to do before, we had to find what that radius was. But when we're talking about quadrantal angles, we already know the radius. It is the distance from here to here, which for us is always going to be 1 unit, right? So our radius is just 1. Cosine is x, so we know we're going to get 1 over the radius, which is 1. So the value of the trig function cosine at 0 is just 1. If we do tangent at 0, so if we're doing tangent of 0, then we know that we have y over x, right? And these just came from those definitions that we did the end of last week for the beginning part of 4.4. And we know our y in this case is 0, and our x is 1, which means that we have a value of 0. Now remember, we can divide into 0, but we can't divide by 0, right? So if you got the 0 on top, it's okay, but if it's on the bottom, it's undefined. So now we're going to look at cosine of pi over 2. Well, that is still just going to be x over r, right? Because that's what cosine is. And in this case, our x is 0. And our r is just, sorry, oops. And our r in this is 1. In every circumstance, our r is going to be 1, right? And so we are going to be left with a value of 0. If we look at tangent of pi over 2, we get our y over our x, right? And in this case, our y over our x is 1 over 0, which we cannot divide by 0, so it is undefined. Make some sense there? So far, so good? Assume that that's just a glorious, overwhelming yes. Thank you. If we look at cosine of pi, well, cosine of pi is still x over r. So we're going to look at this and we're going to go, okay, well, that's negative 1 over 1, which just gives us negative 1. And if we do the tangent at pi, still y over x, doesn't change, right? It's just what is our y over x? In this case, it is going to be 0 over negative 1, which is just 0. And last but not least, our last quadrantal angle is 3 pi over 2, right? So we're going to go cosine of 3 pi over 2, which is x over r, and we know our r is just 1, right? What is our x? 0. So we're getting 0. Tangent of 3 pi over 2 equals y over x, which equals negative 1 over 0, which is undefined. So the real question is, we just did the cosines and the tangent, right? If I asked you to do secant or sine or any of those, do you think you could do them just by knowing what those are? I can't remember right off the bat what they were. I could. If you know that, say, sine is y over r, could you go and do sine for each of these? Right? Well, we know it's y over r, so at this one, we would be 0 over 1. At this one, we would be 1 over 1. At this one, we would be 0 over 1. And at this one, we would be negative 1 over 1. R is 1 because we're just talking about at the angle, right? Every unit is always 1. So the radius is just the distance from here to here, which we know is 1, right? The distance from here to here we know is 1 in the y direction. So we already have the radius built in. That's how we got the r. That's why we didn't have to do the math to find the r in this one. Because it's right on the line. We already know that distance. This is a unit circle. Its value is 1 unit. Does that help? Okay. Anybody stuck on that at all? All right. So that's all we really have to do with quadrantal angles. And what you're going to have is you'll have within your assignment, they're just going to ask you to do it for like sine or cosecant. And all you have to do is go back to that definition that we had last week where it listed them all, right? We had the list of every single one of them last week. So if you saw cosecant or cosine, if say it was let's see, cosine is x over r, so secant would be r over x, right? So it would be 1 over 1 here, and 1 over 0 here, and 1 over -1 here. So that's all you have to do is when you're asked to do those, just go find what that part of the definition is. Is it x over y? Is it r over x? And fill in your blanks, right? Solve them out at each of the locations. The next thing that we're going to talk about is reference angles. A while back, we worked on coterminal angles, and this kind of plays off of it a little bit. When we're talking about reference, I have to say it like that or I'll forget how to spell it. Reference angles. I'm going to give you a definition first. It's going to be long-winded, just like they always are, but then we will explain it, and you'll be like, oh, that's not so bad. All right. So the definition of reference angles is we're going to let theta, right, which is just a variable for an angle, be an angle in standard position. An angle in standard position. Its reference angle is the acute angle that we call theta prime, right? That's what that little line means. It just means it's prime. Formed by the terminal side. Don't worry, I will explain all of this. Of theta. And the horizontal axis. So this says let theta be an angle in standard position. Its reference angle is the acute angle theta prime. That's just that little line above it. It's how we read it. It's theta prime. Formed by the terminal side of theta and the horizontal axis. So what it's saying is that we have some angle in standard position. Which means it starts here, works its way around here somehow, right? And so that's a regular angle, right? And they're saying that the reference angle is the acute angle theta prime formed by the terminal side. This is the terminal side and the horizontal axis. So this angle from this line to here is our reference angle, right? And it's not always going to be right there. We'll break it down to see what it looks like in any quadrant, but that's all they're saying. This is our angle right here, and then our reference angle is always measured from the horizontal axis. So if we have a First of all, if it's in quadrant 1, if it's over here in the first quadrant, the reference angle is just itself. That angle between 0 and 90 degrees, it's just itself. So if I have it in quadrant 1 and they're asking for the reference angle, say it's a 45-degree angle, the reference angle is also 45 degrees. Because that is the closest proximity to one of the horizontal axes, right? But if it's in quadrant 2, right, quad 2, we would have say an angle like so, right? When we want to find that reference angle, if we want to find our theta prime, right, which is just what we're calling our reference angle, we would take pi minus the original theta, right? If it was in degrees and we wanted to find it, we would take 180 minus theta. If it's in quadrant 3, so now we have an angle in quadrant 3, which means that we're starting here and going to wind up in here somewhere, right? And when we do that to find our reference angle, we've got theta prime. When we want to find that, we're going to take theta and subtract pi, right? Because now this here is our reference angle, right? Here, this is our reference angle. If we want it in degrees, it's going to be theta minus 180. So for quadrant 4, we're going to have an angle that starts here and ends somewhere in here, right? And so this right here, this distance is our reference angle, right? We're dealing with only those horizontals. And so when we want to find our reference angle, or theta prime, in this case, we're going to take 2 pi minus theta. Or if we're dealing with degrees, we are going to take 360 minus theta. So which equation that you use depends on which quadrant that it lies, right? Because we're just trying to figure out what is the nearest distance we have to the x-axis, right? How many degrees lie between that terminal side in the x-axis? It doesn't matter the direction. So we're going to look at some of these, and then I'm going to have you guys do a couple of them, and then I'm going to send you on your way, so to speak. So if we are asked to find the reference angles, it will give us something that we're supposed to find the reference angles of, right? So let's look at A gives us theta equals 213 degrees. So we're going to start with degrees. So we need to know, where does this 213 degrees lie? Which quadrant holds our 213 degrees? Well, what I know is that this is 90 degrees, right? And this is 180. This is 270. And this is 360 or 0, right? So I know that it's going to be in here somewhere. Doesn't matter exactly where, right? I just know that it's going to be somewhere, and this quadrant is going to lie my 213 degrees, right? So we're saying that this is a quadrant 3 scenario, right? And if you look up here, you'll see that quadrant 3 says that when we want to find our reference angle, our theta prime, we need to take our theta, which is 213 degrees, and subtract either pi or 180. We're dealing with degrees, so we are going to just subtract 180 degrees. Where did I get 213? That wasn't even my number. I don't know, but it totally works, so it doesn't matter. Oh, that was one of your checkpoint questions that I had set aside for you. So we're doing that right off the bat. So 213 minus 180 equals 33 degrees. So our reference angle is 33 degrees. Ooh, that scared the crap out of me. I don't even know where my phone is, yet it's ringing somewhere. I was listening to music before you guys came in today. Does that make some sense? I'm going to save my A problem that I originally had for you guys for your checkpoint. And I'm going to come over here and I'm going to do part B, which is, oh, definitely I want to do this one for you. Theta equals 2.3. Well, we have to figure out where 2.3 lies on a graph. So if I draw a graph right here, and I know that this is 0, this is pi over 2, this is pi, this is 3 pi over 2. Well, 2.3 is more than half of pi, right? Pi is 3.14, so half of pi is going to be like 1.5-ish. And it is less than 3.14, so I know that it is going to lie somewhere in this third quadrant. Don't care exactly where, because the math will tell me, right? But I know that it's in quadrant, 2, in the second quadrant, right? Pi over 2, it's going to be lie between pi over 2 and pi. If you don't know what these amount to, like, you should know that pi equals 3.14, but if you don't know what pi over 2 is, use a calculator, figure it out. Is it going to be in this section, this section, this section, or this section? There's only 4 possibilities, right? So now that we know which quadrant it lies in, and we have to do this in radians, so we're going to be in our formula, if you remember, for quadrant 2 is our reference angle, our theta prime, equals pi minus theta. So we're just going to do theta prime equals pi minus 2.3. And you can use a calculator if you want on this and get an approximation. I don't know what 3.14 minus 2, I'm like, because 3.141592.6 forever and ever is. Use a calculator. Pi minus 2.3 is going to be like about 0.842. If you're given a negative angle, say I have C equals, or theta equals, I should say, negative 135 degrees. Let's look at that on a graph. Bam. Ooh, that was a good straight line. It's saying that I am taking this 135 degrees in this direction. That's going to fall somewhere in here, right? Because to go all the way here would be 180 in this direction. So it's going to lie between 90 degrees and 180 degrees in this direction. Doesn't matter exactly where, right? So we'll say over here is our negative 135. But we can't approach it from the negative direction. We need to know what the opposite remember when we talked about coterminal angles. So we need to go, what is the size of this angle in this positive direction? And so we just need to go, well, what's 360 minus 135? And we would get 225 degrees. And so 225 is the angle that we're going to use to find this reference angle right here. So in this case, we're dealing with degrees. We're not dealing with radians. So our theta prime is going to be theta, which is 225, minus 180, which gives me 45 degrees. Does that make some sense to you? Do you guys remember the bit about coterminal angles? I know it was like a section ago, but do you remember how to find the coterminal angles? A little bit? Well, in this case, when we were looking for it, it was just, well, the only time you're going to need to use it in this is to find for a negative angle. So all you would do is take 360 minus whatever angle you're given, right? And it'll give you your coterminal angle, right? Because you're not going to have to do it with positive angles in terms of finding reference angles. You only have to do it when you have a negative. So you're just finding the back end of that. So in this case, it'll always be 360 minus whatever angle you're given. So if I have an angle at, say, I don't know, negative, right? We're going in this direction, negative 25 degrees. We would just go 360 minus 25, and it will give us, I shouldn't do that. I should make it 30 or 40 or something like that so that the math is easy. Let's make it negative 40. We would go 360 minus 40, which is just going to give me 320 degrees in the positive, and then we have that positive side, and we can go ahead and find those reference angles after that. I am not even giving you any assignments in what we're doing for the reference angles, what we're doing with reference angles yet, and how to use them. That'll be in later this week. I was going to say next week, but this is still the beginning of the week. It feels like it's Thursday and not Tuesday to me, but I'm going to have you guys do a couple of checkpoint problems. I want you to give this a shot before we leave here. Expect to be called on at some point. So I'm going to give you 3 problems. I did one of them, so I'm going to change it. I'm going to go A is theta equals 300 degrees. Then you're going to have B, which is theta equals 14 pi over 9. And then C, we've got theta equals 4 pi over 5. So the first thing you have to do is figure out where they are. Give it a few minutes. Take a few minutes to work on it, and then we will be back. I'm going to stop recording because we don't need to record this part. You are trying to find the reference angle. So you're going to use, let me stop.